Alright, so we're starting off with a blank page here because I want to remind you about something that we've used in the past that is a tool that is available to you when dealing with fractions. And we're going to use this to solve some slightly more complicated rational functions. Okay? So let's start off with a simple equation that looks something like this. 1/2 x, okay, plus 3/5 equals 7. Okay, and your job is to solve this for x. Right? If you were to be asked to do this, there's a lot of fraction rules that you need to apply. You need to do 7 minus 3/5. You would need to multiply by the reciprocal of a fraction or divide by a fraction, and you need to remember all those rules. And so we have this nice tool available to us, if we'd like, when we're using equations, where if we don't want to have to deal with the fractions, we can change this problem so that it will use only integer values, only whole number values, right? And so to do that, what we're going to look at is we're going to say, I really want to get rid of the denominators, right, which are the things that are causing these expressions to be fractions in the first place. So we're saying dividing by 2 and dividing by 5, that's bad. Well, if I wanted to get rid of dividing by 2, I would really just multiply by 2, right? If I do multiplying by 2 and dividing by 2, they'll cancel each other out, and the bottom of my fraction will go away. Okay, and I'm going to do the same thing here. I'm going to say if I wanted to get rid of this 5, if I multiply it by 5, right, that one would go away. Okay, so if you notice, what I'm really doing is multiplying by 2 to get rid of this one, multiplying by 5 to get rid of this one. If instead I multiply by both of them at the same time, which in this case 2 times 5 is 10, if I multiply this by 10, okay, I'm claiming that this will cancel out everything in the denominator, and I'll be left with an expression that does not have any fractions left in it. So watch what happens. If I were to do 10 times a half, well, 10 times a half, right, is just 5. Okay, and 10 times 3/5, that's a little bit more challenging to do. If you want to remember, 10 times 3/5, right, I can do some canceling and say that goes into 5 goes into 5 once, 5 goes into 10 twice. So this is really 2 times 3, which is 6. Hey, no more fraction. That's good. And here's where you got to be careful. Just make sure you also do the 10 times the 7, and that's 70. Right? And so ultimately, 5x plus 6 equals 70 is another way of writing the exact same expression. But if you notice, no more fractions to deal with. This is much easier to solve. I can subtract 6 and divide by 5. No more fraction rules to deal with. Right? So here's just a quick summary of what we did, because we're going to apply this to a rational function, right? What I did was I looked at the denominators and I said, make sure that every denominator gets canceled by gathering up each of my denominators, 2 and 5, and putting them on the outside and multiplying the whole expression by 2 times 5 in this case. Okay, so let's try to take this tool that we have to make fraction problems look a little bit simpler, right? And let's apply it to something that looks like this, right? So if I take a look at this, I kind of have the same problem, right? I don't want to have to use all my fraction rules if I don't have to. So if I can make these fractions go away, that would make my life a whole lot easier. So I'm going to slide this over, because what we're going to do now is multiply, okay, something times this to make it go away. So before I can look at what factors need to cancel, the first thing I need to do is fix this. This is c squared plus c minus 12. I'm going to just really right below it say, in factored form, this is c plus 4 and c minus 3. Okay? So when I'm looking at this, I'm going to say, all right, if I want to multiply this whole thing by something, what do I multiply it by? Well, if I want to get rid of a c plus 4, I need to multiply by c plus 4. Okay? And if I want to get rid of this dividing by c minus 3, in the second term, I want to multiply by a c minus 3. Okay? And fortunately for us, since now I'm looking at the factored form of the right-hand side, I'm going to see if I want to get rid of that fraction, I need to multiply by a c plus 4. Hey, look, we're already doing that. Good. And I need to multiply by a c minus 3, and again, we're already doing that. So these ones are already taken care of because the left-hand side had those factors as well. If there happens to be anything new over here, we'd have to multiply by that as well, but we're not going to get all that complicated. Okay, so let's take a look. Let me move this over a little bit, okay, so that we can see all the values. Okay, so what we're going to do now is we're going to multiply. I'm going to say, all right, if I multiply c plus 4 times c minus 3 times this expression, here's what it looks like. c plus 4, and c minus 3 are all in the numerator. Okay, and remember this is over 1, so the denominator is not going to change. This is still over c plus 4. Okay, and then I'm going to multiply 3 times c plus 4 times c minus 3, and that's still over the denominator, which is c minus 3. Okay, and I'm going to do the same thing on the right hand side. 16, okay, times c plus 4 and c minus 3. And when I write the denominator just right above this, you can see that I already had the c plus 4, c minus 3 here, which I'm going to get rid of this just to make it look a little nicer. But we're going to bring down the factored version of c squared plus c minus 12. Okay, and then I'm going to get rid of, well, let's get rid of that little dash. I'm also going to get rid of this just kind of redundant factoring. We don't need that anymore. Okay, so here's my problem now. Okay, I multiplied c plus 4 times c minus 3 across the entire numerator. Every term just got that new expression. And remember, we picked that expression because that is the summary of all of the factors in the denominator. So let's do some canceling now. Okay, it looks like these will go away. Those are c plus 4s. The c minus 3s will go away. Okay, and on the left-hand side, even more nicely, the c plus 4 and the c plus 4, the c minus 3 and the c minus 3, we get lots of canceling happening. Let's summarize what we have left now. Okay, my first expression is now c times c minus 3, which when I write that, I'm actually going to distribute. C times c minus 3 is c squared minus 3c. Okay, and in my second expression, I'm going to do the same thing. Let's just distribute that. That's 3c, okay, plus 12. All right, that's simple enough. And this is equal to 16. Okay, so let's simplify this. This looks a whole lot easier to work with now that we've gotten rid of all of those denominators. Right, so I'm going to say c squared, and that's negative 3 and positive 3. That'll cancel, so it's just plus 12 equals 16. Right, and this looks like something that I can solve using the square root method. So c squared is equal to 4. Right, and that means that c is equal to plus or minus 2. Okay, so let's just do a quick check and make sure that I don't have any issues. I'm going to take plus 2 and minus 2, go back up to my original problem, and I'm going to look for any issues. If I plug in a positive 2 here, I get a 6. If I plug in a positive 2 here, I get a negative 1. If I plug in a positive 2 here, it looks like I get 4 plus 2 is 6. 6 minus 12 is negative 6. No zeros in the denominator. That's good. Not an extraneous solution. And if you go back and you check negative 2, I have the same situation. It's not an extraneous solution, but I had to do a quick check. So I'm going to say my answer here is positive and negative 2, okay, using this new method to get rid of fractions, right? So I know that this looks like a lot of work, right? But we're going to try one more just to get the idea down again, right? Here's my new problem. Okay, a little bit more straightforward, I think, because there's less factoring. So I'm going to look at this one and say, all right, I don't like having these fractions. So again, I'm going to move this over because we're going to multiply it by something. So if I'm going to multiply this, I'm going to get rid of all of the denominators. I need to multiply by all of the unique denominators. So I need to multiply by a p plus 2. Okay, which that's going a little off my screen there. You can't see that. So a p plus 2. Okay, and I need to multiply by a p plus 4 to make that one go away. Okay, so this is my multiplication problem. So here's what it's going to look like. Again, we'll show all of the canceling happening. So my numerator for the first term, this one, is going to be p plus 2 times p plus 4, okay, which were the things that I brought in, times the p plus 7 that was already there. Okay, and that is now multiplied by, that is over the p plus 2. Right? So this now is my first expression, the p plus 7 over p plus 2, there it is, with my brand new factors that I multiplied into the expression. Okay, this is minus, okay, well, this is 2 times these again, p plus 2 times p plus 4, okay, and this is over 1, just to make sure that I see a fraction. And I'm going to do the same thing. I have 2 minus p, okay, times p plus 2 and p plus 4 again, okay, all over the denominator on the right-hand side, which is just p plus 4. So let's do all of our canceling. P plus 2 and p plus 2 cancel. There's a denominator gone. Nothing cancels here because I didn't have a denominator, so we're going to have to deal with this thing in a second. And I have a p plus 4 and a p plus 4 that cancel over here. So let's, again, as we bring this stuff down, let's multiply it all out because we're going to have to put together some things. So this looks like when I multiply together p plus 4 times p plus 7, I get p squared plus 11p plus 28. No more denominator, so I don't have to worry about that. Minus, so I'm going to put this in parentheses because we're going to do a subtraction problem. Well, if I do this, this is p squared plus 8p, or p squared plus 6p plus 8, which I can then multiply the 2 into. So if you want to see the middle step, this is 2 times p squared plus 6p plus 8. And then I'm going to distribute the 2 into that. So this turns into 2p squared plus 12p plus 16. And on the right-hand side, I have 2 minus p times p plus 2. Well, that looks like, all right, I have negative p squared. Well, let's do this in this order. 4. And I have a negative 2p and a positive 2p, which are going to cancel each other out. Okay, and then I get at the end a minus p squared. So again, I'll let you go through, multiply together 2 minus p and p plus 2, and what you'll see is you get 4 minus p squared. Okay, that's a squared, not a cubed. Okay, so here's my problem now. So it's better than before because now it doesn't have any fractions, and I can put together my two expressions. So let's put this together. So this looks like p squared minus 2p squared. Well, that's negative p squared. Okay, 11 minus 12, well, that's negative 1p. 28 minus 16 is a positive 12. Okay, so I'm looking at my problem now, and this looks, again, a lot better than it used to. So let's get my p squareds together. I'm going to add this p squared over. And if you notice, what happens is when I do plus p squared on the left, that goes away. But then I'm also going to do it over here, and it's going to go away. So now here's where I'm at. Negative p plus 12 equals 4. All right, that's more progress. Let's subtract the 12 over. Negative p equals negative 8. And now when I divide both sides by negative 1, I get the final solution that p is equal to 8.